Okay, here's number 12 on section 7.2. So here we have the mean incubation time for a fertilized egg kept at a certain temperature is 23 days. Suppose the incubation times are approximately normal with a 2-day standard deviation. Okay, so the first thing we're asked to do is draw the normal model. The student asked this question, got this right. The mean is on 23, right, which we're told is the average or the mean, and the standard deviation, you can see one standard deviation over is 2, so it's 2 in either way. Okay, so this is a nice picture of our situation. Now we need to find the probability that the egg has hatches in less than 21 days. That would be the area under the curve to the left of this 21, and the student has gotten that right. That's about 16%. Okay, 16% is from the left of 21 over here. Okay, now here comes some trickier parts. So we're supposed to interpret this probability. What does it mean that we say a randomly selected egg hatches in less than 21 days has a probability of about 16%? Well, really what that's saying is that, if we had 100 eggs, we would expect about 16 of them would hatch in less than 21 days, right? If we had 1,000 eggs, we'd expect about 160 of them. 10,000 eggs would be 1,600. About however many you sample, about 16% of them are going to incubate in less than 21 days. Okay. Of course, many others, right? 84% are going to incubate in more than 21 days. So out of 100, about 84, you'd expect about 84 to incubate in more than 21 days. Now, those aren't exactly. If you took a random sample of 100 eggs, you're not going to get perfectly 16 of them that incubate in less than 21 days. But this is what we can expect on average, right? If we did that a whole bunch of times, we'd be really close to 16 eggs. If we took one sample of 100 and then another sample of 100, and we averaged all those samples together to see how many eggs would be less than 21 days in incubation, it's going to be about 16. Okay, be really close. They get closer and closer the more samples we take. So yeah, that's a lot different than the average proportion of the way to hatch eggs of all fertilized eggs in the past 21 days is. Not even sure what that means exactly. In every group of 100 fertilized eggs, 16 eggs will hatch in less than 21 days. So this is closer to the right answer. In every group of 100 fertilized eggs, 16 will hatch in less than 21 days. But that's not accounting for the fact that it's a probability. Probability doesn't tell us exactly what the outcome it does. It tells us what we should expect, right? What on average we should see, right? It doesn't. It's not like if you do this, then this will happen. Probability says if we do this, then probably that will happen, right? And if we do this a whole lot, then really probably, almost definitely that will happen. So that's the difference between like probability and causality. So, okay, part C says, find and interpret the probability that a randomly selected egg takes over 25 days to hatch. So that's just going to be this period over here to the right. Now, given the symmetry of the normal curve, this area under the curve should be the same as this area under the curve. So these actual answers should be the same. Okay. I think what the student answered 84%. And I think they might have interpreted it as more interpret the probability of a randomly selected egg takes over 21 days, because this looks to be the complement of this. So 84% would be the amount of would be the probability that an egg takes over 21 days, but this says 25 days. So this is actually just going to be the same answer that we have above. Okay, so I hope that helps a little bit. Oh, there's more. Sorry, got a little excited there. Okay, so we just have to interpret this probability, right? So the probability in every group of 100 fertilized eggs, 16, round to the nearest integer, 16 eggs will hatch in more than 25 days. Now that's too definite for probability, right? We don't know that for sure, but we can say on average, right? If 100 fertilized eggs were randomly selected, then 16 of them would be expected to take more than 25 days. Right? That's what we'd expect. We don't know that's going to happen, but we expect that to happen. Okay. Okay, so find and interpret the probability that a random fertilized egg takes between 19 and 23 days. Do we have this on the graph? So that's between 2 standard deviation. No, 19 and 23. That's this and this. So we don't exactly have that. We could use the empirical rule to estimate there, but I bet it's just easier for everybody to use the StatCrunch calculator on this one. So all I'm going to do is get the normal calculator going. Except my head's in the way. And the mean is, what did we say, 23 earlier with a standard deviation of 2. Okay. Then we just want to go to the between. Okay. And we're looking between what? Between 19 and 23 days. So 19 and 23. Hit compute. So that's, what, about 47% of the distribution? Around 4 decimal places. What would that be? 4772. Check the answer. Okay, so again, we're just asked to interpret this probability. Really, what we're saying is that if 100 eggs are randomly fertilized, about 47 of them could be expected to be, let's see, 48 here, because we're rounding to the nearest integer. Okay. So would it be unusual for an egg to hatch in less than 17 days? Well, we just need to figure out if the probability that an egg hatches in less than 17 days would be less than 5%. So let's go back to the calculator. And I'm going to go not in the between, but the standard. Let's see what the probability is of hatching in less than 17 days. Oh yeah, that's less than 1%. So 0013 if we're rounding to 4 digits. (0013). So it would be unusual since the probability is less than 5%. Okay, that would be extremely rare. Okay, a lot of parts to that question. So I hope that helps.